I am Manuel Sánchez. Today I will try to talk about template metaprogramming and why you must get this thing or not. Okay, it's your decision, but I will try. Okay. First, a little disclaimer, right? This talk is not about functional programming. Okay. I will try to not talk about monads, about, oh, in C++ you can call functions from objects, and something like that. No. Okay. No more functional programming, please. Also, it's not about having a workstation of 16 gigabytes of RAM and wasting all the RAM and compiling things. No. Okay. No. And I will try it to get this talk in a way it's simple and anybody could get this. Okay, so I try to not talk about the latest metaprogramming tricks or meta functions classes or things like that. I try to talk about real use cases of templates, or let's call it hard templates, not just generics, okay? So there's a line when you see C++ templates that say, this is metaprogramming and this is generics. Where's the line? I don't know, okay? It depends on the people, but I try to not cross the line very, very, very long, okay? So I will try to explain use cases, real use cases of templates, okay, from code I actually brought for work, okay? And a bit of template metaprogramming related to this, and what I think metaprogramming library should look like, okay? So I think we need some kind of standard metaprogramming library, and why I think the current implementations, the current libraries doesn't work, mine include, okay, that doesn't work. So let's cover at the end a bit about that. Okay, who I am. I am menu 343726, okay? It's so hard, I have to change that nick. You can find me on Twitter, Reddit, GitHub, whatever, okay? I'm usually talking about C++, discussing with people, being a lot pedant, okay? I have been doing C++ for 4 years, full time, okay? There's people, I don't know, talking with friends in a park with a bottle of beer, okay? I was doing C++. So instead of doing the usual object-oriented programming of C++, I ended up doing my own metaprogramming library, okay? So last year I worked for Code, the startup that tried to build a dependency manager for C and C++. Okay, Code for me was the way to know about the C++ community, to let me show my work inside the C++ community, mostly to leave my cave, okay? Until they paid me to work on Bust again, but well, another type of cave. So I did a lot of CMake Kung Fu. I wrote a lot of posts on metaprogramming and introduction to templates. And I usually give C++ courses in my university for my mates. And this year I currently work in a business in Madrid called Bytech that does works with embedded devices, okay? Of course, doing templates with embedded devices, okay? And that's a note, okay? I still don't know how to write slides, okay? So I tried a lot of tools. I don't know. Okay, this was what they have. Okay. Okay, templates and metaprogramming. I want to talk a bit about templates. Templates are more or less a smart copy-paste system. Okay, it's true. Templates are usually compared with the preprocessor, saying, no, the preprocessor is just like web. Okay, it just replaces text and it just replaces text and expands macros. And I say, okay, templates are exactly the same, but with types. Okay, that's the same. Then there's usually a compiler guy saying, no, currently we have a smart linker that usually mails out the thing, and the code is mostly fixed and clear, but no, it's copy and paste of code in translation units. So you have to care a bit about this. Okay, there could be a lot of bloating of code and things like that. So it's true that it's a better tool, but take care of it. Take care of it. Okay. You can do tricks like in macros, but it's type safe. That's the idea. It's type safe. Okay. On the other hand, we have metaprogramming. Okay. Metaprogramming is that strange stuff of writing programs that manipulates programs or write programs. Okay. You say, what? Why need that? Okay. There's crazy people. Hey, I am in Berlin. I'm from Madrid, giving a metaprogramming talk. Okay. There's crazy people for everything. Okay, so metaprogramming is not about that kind of stuff. Okay, they think of writing some weird bytes, putting on the stack, and then cast to a pointer function and say, this is executable. Let's call it and cross your fingers. I'm not sure if any OS currently supports that, but well, it's not about that, okay? And you really feel like a hacker, okay? You are in a Starbucks writing templates, okay? And people say, oh, what the guy is doing, okay? He's doing templates, oh, so cool. He's hacking Facebook, no, our templates, okay? And template metaprogramming is just that kind of hacking using the C++ type system to do things, okay? It's just that. With a word syntax based on, it's like HTML, okay? But it's more or less that, okay? This is a definition of programmer I'm sure most of you know, okay? That kind of organism that transforms code and pizza into lines of code, okay? That's mostly true. Then there are C++ metaprogrammers that are organisms with a problem in his brain, okay? That transform lines of code into time to do whatever you like, okay? You have hours and hours and hours for build times, so go for a coffee, take the bike, okay, do whatever you like, okay? So this is a C++ metaprogrammer, okay? You run build and take a rest, it's fine, okay? Sadly, that picture is completely true. Well, okay, so, sorry. I will try to show you two examples of real templates. The second is more, call it experimental. But the idea is to not fear templates, to think that the template system is another tool in this language, and you should know it's 6. You should know you can do some things with that tool, and not just discard it, throw away the template system and say, no, I don't know about templates, no. I only do object-oriented programming and C with classes, no, okay? Okay. And the first case I will try to explain you is array views, okay? Okay. This is mostly what I was working the last 3 months, okay? Working in a TCP/IP-like protocol for communication, okay, for embedded devices. A protocol that looks mostly like this, okay? You have the low-level frame, okay, with all the checking metadata, error code checking, the payload of the data, okay? Then there is another layer in the stack that just takes part of the frame and processes it, and again, okay? So the linear implementation did something like, okay, we have the payload from the user, then append in the array a header, then append metadata, then append a CRC code. And the first time I look at that, I said, this is real time, yeah? Really? This is real time, appends of an array with a dynamic allocation and all this stuff. When you know perfectly the length of the frame, okay? So I said, let's write an array view, okay? Instead of playing to join arrays, isolated arrays, let's build an array at the beginning and then just read the array with code syntax, but it's just an array, okay? You have to know some context on this. The pipeline mostly works like this. It's from the input, it just receives a frame, takes the frames, does something with it, and then discards the frame to trash. Okay, and output is exactly the same. It's building the frame, sending to the terminal, and then discard the frame. So the goal for the system is being fast when processing the different layers of the stack. Okay, and this is not an original constraint in the specification, but what's mine? I tried to write this in a way that the code looks like usual C++ code, okay? Like a usual C++ class with its data fields and things like that, not worth template code that only I can understand, okay? The array view. Let's check a bit the array view. It takes an array of bytes from Qt, okay? And just wraps the array in a non-owning view, in a non-owning way, okay? So the array view doesn't know anything about who has to delete the array, who has to move the array, things like that, okay? It's just only some kind of classes on the array, okay? And this array view only looks in a definite range, that is this begin and end, okay? So it's very simple. You only have an operator for reading and writing, and an operator to take more slices, okay, and methods for easy manipulation of the slice, okay, like give me whatever bytes there are in this part of the array as an int, for example, okay. Okay, and that's the idea. We do implicit serialization through the read and write methods, okay? Can be implicit. Actually, my code are implicit through operators, but just for clearness, I'll leave it like this without implicit operators, okay? Transparent serialization. It's just a call to the Qt API, okay? There's no word magic, okay? This is simplified, Okay, you have to take into account the endianness of the serialization. For example, the T type, the template has maybe 4 bytes long, and the slice is 2 bytes long. You have to take into account that, but it's mostly this. Okay, just take the slice from the original byte array, and then write using the API. Okay, it's only that. Okay. And this is problematic. Byte array does copy and write implicitly. So, for example, if you write this slice, okay, you do slice equals 4, okay, that doesn't write the original byte array, since it's really a copy of the array. Okay. Well, recursive slicing. The array view has the ability to get slices that are themselves other array views. In a way, you have, for example, a view of 32 bytes, for example, and then you take another view from the original view of 16 bytes, okay, and then recursively. So you end up, let me go back, with something like that, okay? The idea is that this is the way you take a view of that view, you take a view of the view, and again. So no location is needed, just the original for the complete frame, okay? Any questions? No? Okay. Array. No. Okay. And this is mostly how the code at this time looks like, okay? Just say, give me the first 2 bytes of the frame, okay? Read as a 16 bytes number, and then check is equal to the frame header constant you have. Okay, that depends on the implementation or the specification on the protocol. It's just an example. And then you can take, for example, the payload as another part of that is another slice of the frame. Okay. Well, recursive slicing is just implemented by having another constructor that takes the array view and takes the new begin and the new end and just adds up that iterators. Okay. Now, if you have an original slice from 2 to 8, and you do 0 to, you end up doing 2 to 4. Okay, that's the final slice. And the operator call just calls this constructor. Okay. For bonus, you can write the calls to write and read as a proxy class. So you can directly return from functions the thing that actually does the read and the write. Okay, that will be useful for later. Okay, it's just okay. Another improvement: write a viewable array. Okay, it's an array that it's at the same time by a cubate array and another view of that same array. Okay, you have to take care of the pointers and that implement 5 special functions of the class, but works perfectly. Okay. Then you can, for example, easily write a frame following the specification you have for the protocol. Okay, like for example the header, the source address. Okay, you write code that's exactly like this. Okay, give me the header of the frame, check it's equals to what the specification says, check the payload. Okay, you can build the frame from a cubate array, then assign a new value to the address, okay, and then send directly to an API that works with Q beta arrays, okay. Any question? Great. The idea of this example is to not be afraid of templates, okay? It's just another tool. Actually, that code is not complicated at all, I think. So it's just a simple example. More things you can do. You can represent frames, request frames as objects, okay, as classes and instances of that classes. And have the data fields usually will write as an struct, okay, as an integer field and a string field, etc. You only write that as reader and writers, okay, and the frame is exactly the same as in the original code, okay. You can come to Bytech and see the horrible implementation I have for this, okay. Okay. The second example I want to show you are named tuples. Okay, I have a personal feeling against the C++ tuples in general, because you cannot index tuples at runtime. Actually, the index at the compile time has a syntax that's kind of weird. So let's see if we can improve that at least a bit, okay? And I say, I don't like stdget, okay? It's horrible syntax. Also, for this kind of code, usually write C structs for data, okay? For cases where the data itself doesn't need any operation, so a class, an object-oriented class, has no sense, okay? It's just a package of data. The advantage of tuples versus structs are that the layout of the struct is fixed, okay? But the tuple, you can manipulate the tuple or the definition of the tuple using metaprogramming, okay? So you say, I need a tuple of an int and a string, for example, but with padding in the middle of the fields, okay? And instead of having to write a dummy array of chars empty that you don't use for anything, you just say, okay, give me a tuple with an integer and space left and a string, okay? So the goal for this example is to have mostly human-readable tuples, okay? Mostly customization tuple, okay? And this is the most important, I think, to have element access of tuples independent from the internal layout the tuple has, okay? This is the ideal code I want to write for this, okay? You have a make tuple that you pass a key as a string, the value, okay? The type is inferred from the value, like the STL make tuple, okay? And just other entry, E, with the value of the constant E. And then you access the element of the tuple using brackets and the pi, okay? The pi string, okay. How? Well, that underscore, okay, it's a kind of trick. Just write an user-defined literal, okay, that does all the magic under the hood, okay. And then when the magic's done, we have to map from that strings to the real elements in the tuple, okay. So how doing Hasin? Oh, there's a H missing. Okay, well. We have to do Hasin at compile time using concept pair. We can use meta functions like using recursion and templates, but I said I don't want to waste all your RAM doing Hasin of strings. Okay, so I end up using concept pair. So just write a function that computes the hash of a string, okay? Then write an user-defined literal that takes an string literal and computes the hash, okay? Sadly, this doesn't work. Okay, it's the code, okay, the user experience code, it was mostly cool, but we have currently no ability to process a string literal with a template. Okay, we need that to really traverse the string. There's no way. The only overload for the string literal is this. You cannot make the type depends on the value of the parameter. Okay, that's the problem. So there's an alternative that is having a string literal operator that takes a pack of chars. Okay, a template pack of chars, but it's not. I think it's not accepted currently for C++ 11, but. So the way to follow with this is using macros, okay? Simple macros, but I hate the preprocessor, but we have to use macros. Okay, so the example from the other slide ends up like this. So there's an edge like hash, okay, that takes the strings and then a tuple get right there. The tuple get is really not this, but it's fine. So, well, you notice that the thing is exactly the same like before, but in a macro. Okay, just calls the hash function and stores it in an integral constant. Okay. If you do the hashing right, okay, you have to map from the hashes to the real indices of the tuple, okay, because it's behind all this magic. It's really a C++ tuple. So you have to know the index, and you have to know the relation between the string and that index, okay. So you have to write a compile time hash map. Okay. A compile time hash map is something like this. It's a trick. This code is not mine. Okay, it's from Louis Dion, the author of Boost HANA. Okay, there are multiple ways of doing this, but this is the most performant way from the compile time view. So the trick is you have a function named Lockup. That takes a par k value and returns a value, okay? And the trick consists in calling that function in a way the only call result is the one that has the key you passed to the call, okay? So the trick is, let's have a set of pairs, okay? You build a type that is the aggregation of that set of types. That's why it's inheriting from all the pack. And then if you take a pointer, you're really using all the class and the base of the class and the base of the class and the base of the class, okay? So when the compiler sees a call like this, says, okay, I have to try to call the function lookup with inherit from pairs, then the first pair, then the second pair, then the third pair, until one call matches, and you have your value right there. So you just have to do the cloud type, okay? Any problem until there? Okay. 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 Then our tuple. We have the mapping system, we have the hash. Now we have to build the tuple itself. So we look at the tuple. It's something that takes a set of keys, a set of types, and does internally the mapping. Okay, so this takes a pack represented as a tuple of indices. Okay, then a pack of the types, and ends up building a really what is a std tuple of that same types. The only trick is to do the mapping internally. That's why we have that all that kind of stuff for hashing and mapping and that. Okay, the type is finally just an std tuple. So we have an alias right there that computes the final index from the hash of the string. Okay, and our get for the tuple just calls std_get, but calling first the alias that computes the mapping. Okay, so you end up with the mapping policy you brought. Okay, and you have also this operator right there. So the macro tuple get is not really needed. Okay. 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 So I really use tuple as backend just because the code has to fit there. Okay. So there are multiple ways of writing this. You can write your own tuple. You can write a proper std tuple with your own properties. Okay, but it's just an example. You get the idea. Okay. To make the layout of the tuple customizable, you just have to change the mapping policy. We wrote a map that maps directly the hashes to the index of the element we are searching for. But you can do whatever mapping you want. Okay, you can map like. For example, you sort types in increasing size, for example, for catch efficiency, or whatever you like. Okay. In a way, you map the names of the members to the tuple that it's exactly the same. Okay. Well, the tuple, if you take, let me, if I will to go back again to the example. Okay, we have this function. Okay, that magically takes pairs of string hashes and values. Okay, so that's not that simple, since you have to actually build the tuple. Okay, from that. So how that works? Well, I will show you only the first part, okay? Because there's a lot of code just for that. So actually, there is many more code just for building the tuple than the tuple itself, okay? That's it. Okay, so how we build tuples? We want to take a pair of a hash and a value, a set of that pairs, and then build a tuple from that. Okay. So first of all, we define an entry type that has the hash and then the type the hash represents. Okay. Then a meta function that takes a set of entries, okay, and recursively expand the set of entries to get the final call to the final template that is our tuple. Okay, if you check the code, okay, the final tuple is the tuple you have by expanding each entry pair by pair. Okay, you have, for example, you have tuple of a pair, okay, that's a hash, then a type, and when you have that, you just expand all the things. So it's like unroll it, okay? Okay, and the final type is just calling that with a set of numbers to generate the indices. Okay, that's the point when you can change the layout policy. Okay, and at this code, I brought directly, okay, generate me a sequence of 0, 1, 2, 3 of the length of the type spec. You can write there whatever you need. Okay. And then a tuple is just the result of that meta function. Okay. Okay. You have the complete code. This is code you can actually try. Okay. I have it in my GitHub account as a guest. So you can directly copy and paste to an online compiler, and it works. Okay. And finally, I will talk a bit about what to say later. How a metaprogramming library I think should look like. Okay, because there are currently many alternatives. There is Boost HANA, there is the Meta library inside Range v3. There are a lot of stuff for that, but you usually have to install the latest compiler. So this is the kind of metaprogramming library I want to look at. So why a sandwich? Well, this is the kind of slide a normal person would write a diagram with a stack, with the architecture of your library. I said, okay, a sandwich. Okay, you have layers. And that's my stack architecture. So the idea is that you have to write a library that's compatible with at least C++11, okay? If you want metaprogramming before C++11, go to Boost, take MBL, and it works, okay? But at least we have to support C++11, okay? Actually, the real problem is that no library for metaprogramming out there really supports C++11. Okay, you have to work with GCC 4.9 or something like that. I'm sure there is maybe there are people, no, but there is little number of people that works with things like GCC 5 or GCC 4.9 or something like that. Okay, so if you need this kind of stuff, please write in a way people can use it. Okay, so for example, Range v3 cannot be built with the latest release of Visual Studio. Okay, that's a problem. That's a real problem. You can write the coolest library in the world, but if nobody can build it, it's not stable at all. Okay, that's a real problem. So the sandwich, the idea of the sandwich is to write a bottom layer with all the core stuff, okay, only with C++11, okay? Then when you have that layer ready, you can write all the wrappers you like, all the cool stuff with C++14, variable templates, whatever you like, okay? But first, give me a core C++11 compatible, okay? Because at work, I work with GCC4, okay? I want my library working at work. So please, give me something really useful, okay? And when that part of the jam works, okay, and the C++14 sugar, call it, works, you can think about whatever, concept slide, metaprogramming with concept slide, and C++17, things like that. But first, get the bottom layer of breadth first, okay? And, okay. And that's all, okay? We'll be glad to talk more about complex metaprogramming, okay? So, talking about meta functions and functional programming is easy. It's very easy. You can take whatever repo you have in your house and say, yeah, let's talk about this cool meta function, but that's not useful at all. Okay, I prefer to talk about something that maybe it's much simpler, but it's more useful. Okay, from a practical point of view. Okay, so that was my idea. I'm not sure it's your opinion. But that's all. Any question? Okay, thank you.